Hello and welcome to Empowered Learning. This video will be about how to look at word problems and from that form a Venn diagram to answer questions, as well as looking at survey problems. We'll start off with a simple word problem and form a Venn diagram for it so that we can answer some questions. So we have 18 members that are in an investment group and they decide to take 3 classes or seminars. And so one of the classes is real estate, the other one is stock investing and trading, and the last one is commodities. And so we want to figure out, well, we're given information about what the actual members in the investment club did, and we're going to see that below. And then after we look at that, the first thing that we're going to do is form a Venn diagram of the situation. And we want to identify how many members are in each region, meaning how many members actually took the real estate class, how many actually took the stock investing class, and how many took the commodities class. And so we're going to answer these questions below here as well. So to start off, we see that we have 7 members who took the real estate class by itself. We see that 10 members took the stock investing and trading course, and we see that 5 members took the commodities trading class. And so we know that all 18 members of the investment club took one class, and we know that out of those 4 members took both the real estate and stock investing course. So we have 4 members that actually took 2. And the last thing is that we know no one who took the commodities course also took the other 2 courses. Okay. So in looking at that, we can start off with our Venn diagram as identifying some sets. So of course, we know that our real estate set is going to be R, our stock investing and trading set is going to be S, and our commodities trading is going to be C. And so what I'm going to do is I'm going to make a circle here with just the one for real estate, and we'll make another one here for the one with the stock investing. So we'll call this S, call that R. We will interpret the set C, which is here, as being the set that is outside of the real estate and the stock investing and trading courses. Okay, and so we want to look at it like that because we don't want to consider C as being what's called the universal set. Okay, so it's just basically what is outside. So to put it one way, the set C is going to be the complement of the union of real estate and stock investing. Okay, so we know that we have this setup. If we scroll down, you'll see here that no one who took the commodities course also took the other 2 courses. And we were told that 5 members actually took the commodities course. So we're going to start there. And so what we'll do is I'll do this in a different color. We'll just put the number of people who actually took the course. We'll put that in another color here. All right, so looking at that, we know that 5 people need to be on the outside. Now I'm just going to put it in black. Now the other information that we know here is looking from the inside out, we know that 4 members took both the real estate and the stock investing trading courses. So looking at our Venn diagram, we see that this area right in here is the intersection in between the real estate and the stock investing courses, and we know that 4 people took that. So we'll go ahead and put 4 there. Now, once we have that, we also know how many people took the real estate class, which was 7 members. So we already have 4 here in the intersection. So that means to get 7, we have 3 that remain. We also know for the stock investing and trading course, we know that 10 members took that class. Okay, and so since we already have 4 that are here in the intersection, that means we have another 6 that are that just took the stock class all by itself. And so if we add up all these numbers, which would be 3 plus 4, which is 7, 7 plus 6 is 13, and 13 plus 5, which is 18, you see that we have the total 18 members that our question originally talked about. Okay, so we've actually formed the Venn diagram, and so now from this we can answer many other questions, and so we're going to go and actually do some of that now. So let's see, we need to first identify how many are in each set here, so I'll go ahead and do that. So we know that the number of people that are in the real estate, that's going to be 7 here. And we know the number that is in stocks class is 10, and the number that is in the commodities is going to be 5. So that's how that would actually look here if we were doing it in cardinality notation. Okay. All right, so now we can look at our Venn diagram and easily answer some of these other questions. So it says, how many of the members took both the stocks and the real estate? Okay, so of course, stocks is here, real estate is there. We already know that the answer to that is 4, because both, meaning intersection, is just going to be 4. How many took the commodities or real estate? Okay, so commodities or real estate means that we want the total collection of who comes from one set or the other. So the number of people that took the commodities was 5, and the number of people who took the real estate is going to be 7. And again, we see here that no one that took the commodities class actually took the real estate class, so they're separate. So we have to add these two together, and of course that would be a total number of 12 people. Okay. If we look to the next question, it says, how many took neither real estate nor stocks? So that means how many people did not or do not belong in the set R or the set S? Well, we know that that's exactly the number of people who took the commodities class, because we know that everyone who took the commodities class did not take the real estate or stock investing class. So that would be 5 people. Then the last question is, how many took real estate and commodities? Okay. And so, and meaning they took both classes. And if you notice, everyone who took the commodities class did not take neither the real estate nor the stock class. So the answer to that question would be 0. Okay. And so that's how we can actually take a word problem and from that form a Venn diagram. And then from the Venn diagram, we can easily come up with some answers to questions analyzed in our situation. Now let's look at our next example. All right, so in our next example here, this is a little different from what we've done before. And so what we have is a Venn diagram that is labeled according to region. Okay, and so if you see the Roman numerals there, what they are referring to is regions. So as an example here, let's say region 3 is the intersection of sets M, W, and H all at the same time. It does not mean that we actually have 3 members that belong in that set. And so how we would write that out would look something like this. Region 3 would represent the intersection of M, W, and H. Okay, so we're just trying to label that. The point of this example is to see if any members exist in these particular regions according to how we have defined them. And so our set M is going to be the set of all things that are mammals. W is going to be the set of all things that are whales. And H is going to be the set of all things that are humans. And so we're going to use our common knowledge and ask ourselves, could we actually have a member in these particular regions here? Some of it will make sense, some of it will not make sense once we start reading it. So our first region, we want to know, would anything exist in a set where all mammals that are neither whales nor human? Okay. So what that looks like here is all mammals, so that would be our set M here, that are not whales. So in other words, a mammal that is not a whale and a mammal that is not a human. If you can think of a mammal that is not a whale and a mammal, or a mammal that is not a human, then there's something that can be put in region 1. And for instance, a dog is an example of a mammal that is not a human or a whale. So here we could actually say yes, region 1 here would have at least one member. Okay. Region 2, which is right here, we understand that to be all mammals that are also whales. Okay. And so if you know anything about whales, you know that whales are considered mammals. So in that sense, we can say yes, region 2 would actually have members. For region 3, we say that would be all mammals that are whales and human. And another way of saying that, jokingly, is to say, do we have any whalenoids walking around? Okay, mixture of a whale and a humanoid, and I don't think so. Okay, I know there was a cartoon way back in the day called Jabberjaws, but of course he was a shark, so that's about as close as we could get to that. So anyway, realistically, we would have no members in that particular region or in that particular set. So for region 4, which is right here, we want to say all whales that are neither mammal nor human. And so, of course, a whale is not human, so that's okay. But since we know that whales are mammals, there's no way for a whale to not be mammal and actually exist. So in that case, we would have no members in that set. All whales that are not mammals but are human, okay, that would be what region 5 is, and that's what this represents here. So if you know of a whale that's not mammal but just so happens to be human, please let me know, because I don't know any. Okay, so because of that, we know that there won't be any members in this set either. Moving on to region 6. So region 6 is right here. And so what we want to do is actually interpret that and then say, do we have any members? So here, if we look at this, this will be all humans that are, and I'm just going to do it in broken words, that not, since I have limited room here, that not male or whale, mammal or whale. And I'm just going to say mammal or whale. Okay. So do you know a human that is not a mammal, or do you know a human that is not a whale? Of course, we know humans that are not whales, but there is no human that exists that is not a mammal. And so here we know that there won't be any members in that set. And just in case you don't know, if you're trying to figure out what a mammal is is a species to where basically the young actually feed off of the milk of the mother. Okay, so basically, if a species is able to produce milk or some sort of food for their young, then they are considered a mammal. So that's what we mean when we say that. All right, so for region 7, which is here, we have, and remember here, this is set M, okay? So we see here we have the intersection of M and H, meaning that this is all things that are mammal and human, but not whale, okay? All things mammal and human, but not a whale. And of course, we know that mammals, well, we know that humans are mammals, so that makes sense. And we know that humans are not whales, okay? So if you can think of something that is male, mammal, and human, but not whale, namely a human, and of course, if you're listening to this, then you are probably a human, so you need to say that there is at least one member in region 7. All right, so for the last one, region 8. Region 8 is understood to be all things that are neither mammal, human, nor whale, okay? And so if you can think of anything that is not a mammal, that is not human, and is not whale, then you need to say that you can have a member in that set. And of course, there's many things that fit that. A mosquito, for instance, is an example of that. A snake is an example of that. Okay, so here we know that we can have members in that particular set. And so this concludes the example on how to take a Venn diagram per regions and how those regions are defined and figure out if they have any members in them or not. All right, so that concludes this video. In the next video that I'm going to do, I'm going to get into the survey problem examples. And so please check that out if you're looking for that. Take care.